Hello everyone, today we can discuss how to calculate electronegativity by using simple trick. How to calculate electronegativity by using simple trick. Now at the end of lecture I will teach something very special, the difference between the electronegativity and dipole moment. The many of students do not know and they misunderstanding them. Now, what about electronegativity series in the periodic table? Electronegativity series in the periodic table. Now, I write hydrogen. Now, I write hydrogen. Okay, lithium, sodium. Now, beryllium, magnesium. Beryllium and magnesium. Now, boron, carbon, nitrogen, oxygen, fluorine. Now aluminium, silicon, phosphorus, sulfur, chlorine. Now I made two arrows and two circle. I made two arrows and two circle. So the lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, it belongs to second period. Now sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, it is a third period. Now I made two arrows. See the first arrow in second period. See the first arrow, second period. Okay, now the second arrow up from sodium to phosphorus. Sodium to phosphorus. Leave the last two elements by using circle. By using circle, sulfur and chlorine. Now here hydrogen also we made circle. Now see the lithium. It is a 1, its electronegativity 1. Now beryllium I am increase 0.6, 1 to 0.6, I will increase 0.6, it is a 1.6, it is a 1.6. Now the rest of elements to increase the 0.5, rest of the elements increase the 0.5. So for example it is 2.0, it is 2.5, it is 3.0, now it is a 3.5, it is a 4.0, 4.0. Now, see, look at for sodium. For example, sodium, its electronegativity is a 0.9. Now, I am increase 0.3. Every element increased 0.3. The magnesium is 1.2. Aluminium is a 1.5. Silicon is a 1.8. Phosphorus is a 2.1. Its electronegativity. Listen carefully. Now the circle of elements chlorine and sulfur. Chlorine is a 3.0. Now sulfur is a 2.5. 2.5. See, now hydrogen is a 2.1. Hydrogen is a 2.1. Now, according to this series, at the left hand side, so this is the left hand side, it is the left hand side, electronegativity decreases, at the right hand side, electronegativity increases. What is the right hand side? It is a right hand side. Now down the group, electronegativity decreases. Down the group, electronegativity decreases. Electronegativity decreases. Now the fluorine is the highest electronegativity in the periodic table. Fluorine is the highest electronegativity in the periodic table. Now I am telling about one small trick. If electronegativity difference is 0 to 0.4. The electronegativity is 0 to 0.4. It is non-polar. It is a non-polar. If the electronegativity difference is in between 0.5 to 1.7, it is a polar, means non-polar covalent and polar covalent. If electronegativity difference is 1.8 to 4, it is a ionic. Bond. See, it is very important to calculate whether the molecule is polar or non-polar or ionic bond. By using this trick, we can easily find. Let's calculate some compounds electronegativity difference. Let's move on. See, now let's calculate electronegativity given compounds. For example, I am taking HCl. Now look at for table. The chlorine, its electronegativity is the 3.0. Hydrogen is the 2.1. I subtract 3.0 minus 2.1. It becomes, what is the value? 0.9. The difference is 0.9. It is greater than 0.5. The greater than 0.5, it is a polar. It is a polar covalent. Let's take second example. Phosphine PH3. The hydrogen is the 2.1. Now phosphorus is the 2.1. I subtracted 2.1 minus 2.1. It is equal to 0. 0 to 0.4. The difference is 0. It is a non-polar. Now thirdly, sodium chloride. The chlorine electronegativity difference is 3.0. The chlorine electronegativity is the 3.0. Sodium is a 0.9. I subtract 3.0 minus 0.9. It becomes 2.1. 2.1 means it is the greater than 0, greater than 2. Greater than 2 is the ionic bond. Let's take example. Water means H2O. Oxygen is a 3.5. Hydrogen is a 2.1. I subtract 3.5 minus 2.1. It becomes 1.4. 1.4 means it has polar covalent. 1.4 means in between 0.5 to 1.7. By using this simple trick, we can easily calculate the electronegativity difference. Finally, let me teach you the difference between the electronegativity and dipole moment. Electronegativity and dipole moment. Let's move on. See, electronegativity and dipole moment. See, electronegativity and dipole moment. Dipole moment. See, electronegativity means it measure how strongly an atom attract shared pair of electrons is the electronegativity. It measures how strongly an atom attracts a shared pair of electron is the electronegativity. For example, I am taking CO2 molecule. CO2. It is a CO2 molecule. So look at for oxygen. It is a 3.5 electronegativity. Carbon is the 2.5. I subtracted 3.5 minus 2.5. 3.5 minus 2.5. It becomes 1.0. 1.0 means what? It is a polar covalent. It is a polar covalent. 1.0 means it means it is reference between 0.5 to 1.7. Now dipole moment. See, dipole moment means it measure net polarity of molecule. Let's take example CO2. Now oxygen exerted 5 Newton force, shared pair of electron this direction. Another oxygen also opposite force is 5 Newton. The net polarity equal to 0. The net polarity equal to 0 means it is non-polar molecule. It is a non-polar molecule. Now this is a difference between electronegativity and dipole moment. Thank you.